Okay, so if you can solve this math problem, you definitely have strong math skills. Let's take a look at the problem. So we want to determine the boat's true speed and direction. So we're looking for true boat speed and direction. And here is the scenario. We have this boat and it's traveling due east. This could be in some sort of like river or some sort of body of water, a lake. But it's traveling 15 knots due east. But we have a current in the water, and that current is 2 knots going due south. So the boat's true speed and direction is going to be affected by the current. In other words, the boat's not going to continue on its path. It's going to be pushed in some direction by the current, and that's going to change its speed. Now, you definitely need a calculator to figure out the answer to this problem. But if you can solve this thing, well, go ahead and put your answer into the comment section. I'll show you the correct answer in just 1 second. Then, of course, I'm going to solve this problem step by step. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, well, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. All right, so one more time, we're looking for the boat's true speed and direction. Now, even if you can't solve this problem, try to maybe use a little bit of, oh, I don't know, common sense, if you will, to think what's going to happen to the boat, right? So the boat's going 15 knots. Now, if you don't know what knots is, this is basically the way we measure speed out on the ocean or the sea. But, if you want to exchange that with miles per hour or kilometers per hour, go ahead, right ahead. It doesn't really make a difference because, whether we're using knots or miles per hour, the answer is pretty much going to be the same in those respective units of measure. But this boat's traveling due east, and we have a current that's going to be pushing the boat. Okay, so what's going to happen to the direction of this boat, and how do you think it's going to affect the speed? Is it going to make the boat speed up or slow down? All right, so let's take a look at the correct answer. The correct answer to this problem is the following. The boat is going about 15.13 knots with the current, and its true speed, or true direction, excuse me, is about 97.59 degrees. Okay, so that is the answer, and if you got this right, you definitely get a happy face, A plus, 100%, and a certificate of excellence because you appear to be a certified professional expert in the basic concepts of vectors, and that's what we're talking about here. And not only vectors, we have to do some basic trigonometry and geometry to get the solution. But if you're like, hey, Mr. YouTube Math Man, I'm totally confused. This looks too complicated for me. Well, it's not that bad. I mean, we do have some, decent amount of work to do. But let's just take a look at the problem from a kind of common sense standpoint. Okay, so we have this boat, and we're looking for the boat's true. When we say true, that's the actual speed and direction when we account for the current. All right, so first things first, I'm going to have to define what true means in terms of a compass. We got north, south, east, and west. But let's just kind of put that aside for a moment here and just imagine we have our boat traveling this direction. Okay, we'll call it east, and the current is pushing against this boat. Now we have a small current relative to the speed of the boat. So if you're saying, hey, Mr. YouTube Math Man, I think the boat is going to maybe get, pushed a little bit to the right. Now, when we're talking about nautical terms, that means starboard. But again, we don't have to get into all that. By the way, this particular problem is a little bit near and dear to me because in a former life, I used to be a U.S. Navy surface warfare officer. I actually did this for a living, but the boats that we used to drive were big Navy ships, and that was a pretty good, pretty cool job. Matter of fact, it was an excellent experience. But anyways, let's get into this. So we know that our little boat is going to get pushed to the right, right? So it's going to, if in other words, if we're trying to get to this destination and we're like, all right, let's go due east here. Well, if we have a current, it's going to push us this way. But also, do you think it's going to make the boat speed up or slow down? Okay, well, we're actually going to speed up a little bit because the boat's going 15 knots, And our answer is, let's go back to the answer again. The speed, when we account for the current, our true speed is going to be 15.13 knots. So it's going to help us out just a little bit. So we need to talk about a couple major concepts here. The first is vectors. Now, vectors is a huge topic in math, trigonometry, and particularly science like physics and whatnot. Vectors are everywhere. And if you never heard of a vector, well, it's a pretty simple concept. Basically, vectors are ways to represent things with speed and direction. So, for example, this boat here, we can represent it with a vector, which is effectively like an arrow. Okay, we have an arrow here, and the length of the arrow represents the speed. Okay, so if this is 15 knots, if we double the length of this arrow like this, well, this would represent 30 knots. Okay, if we made this arrow real small like that, maybe that's like 5 knots. But we also have to account for the direction of this arrow. Okay, the arrow is pointing due east, and that makes a difference. Okay, so basically, a vector is accounting for direction and speed. So this vector or this vector is different than this vector or this vector. All right, so real basic concepts of vectors, and we're going to see how we're going to use them here in a second. But the current here, if you notice, its arrow is smaller than the 15 knots. Well, that's because it's 2 knots and it's pointing in the south direction. So a vector, basically you can kind of think of it as an arrow that the length of the arrow represents the magnitude or speed, and the direction of the arrow represents the direction of that speed, okay, or of that object in motion, or things like wind or current. All right, so hopefully that makes sense, and we'll get back to vectors here in a second, but we need to talk about this compass heading business. So we're talking about true, right? So I'm saying, what is the boat's true heading or direction and speed? And when you measure direction, pretty much you have true versus, well, you could say like magnetic. Okay, and I don't want to get overly navigational here. In my last job in the U.S. Navy was actually a navigator of a big, very expensive warship. But that was an awesome job. But anyways, what you need to know is when you have your lovely magnetic compass, that compass, right, when you say, oh, it's pointing north, well, it's not actually pointing due north. In other words, here is the Earth, here is the North Pole, there's the South Pole. Your compass is not, your magnetic compass is not pointing due north. Okay, it's actually pointing over here by Canada. There's a big, huge iron ore deposit. So we have things called deviation and variation, things to correct our compass, but that's a whole nother different deal. So that's magnetic. Okay, so when you have a magnetic compass, it's pointing to magnetic north. What we want is true north, and true north is the actual true north, right? So here is north on the Earth. So to get that actual true north, well, then you need like a gyro compass. But anyways, that's what we're talking about here when I say the word true. Okay, so true north is going to be 0 degrees. So if we want to go true north, we'll have to point our boat 0 degrees and go in that direction. Now, if we are going 90 degrees, okay, or 090 degrees, that's due east or true east. Now, if we're going 180 degrees, that's due south, and 270 degrees is due west. So basically, we measure this way on a compass heading. All right, so for example, 45 degrees is what? If we're traveling 45 degrees true, we are effectively going northwest, right? So here is our 45 degrees. Now remember, we're starting from the north. On a compass, it does start right up here north with 0 degrees. So if I was going 190 degrees, right? So all right, let's go 190 degrees. We're going to go this direction right here, 190. All right, now a lot of you are saying, Mr. YouTube Math Man, you're giving me a whole lecture on navigation, compasses, yada, yada, yada. Well, you need to understand these things, especially if you're going to get into more advanced mathematics and things like physics and science. Okay, so if you never heard of this, we're going to combine the concept of vectors and our true headings here to solve the problem. Okay, so let's talk about vectors again. So a vector, Remember, it represents speed and direction, our arrow. And what we're going to do is basic vector math. Now you might be saying, vector math, what is that? Well, I'm going to show you this right now. By the way, too, this word vector, you may have heard this in, oh, I don't know, various maybe movies or videos, especially when they're talking about, oh, like aircraft, right? So if there's, maybe even like Top Gun, I'm thinking. So, the air traffic controller, somebody says, hey, vector your aircraft to this destination. What are they saying? Hey, go in this particular speed or go in this direction at this speed. Okay, so that is, again, a vector. So every time you hear that word, you'll know what it means. But what we're going to do here is use vector mathematics to figure out the true direction and speed of the boat. And we're going to literally add these arrows up. So here's our boat. It's going 15 knots due east. Okay, so its arrow, the arrow is pointing east. Okay, so you can see there's my little arrow right there. And then here is my current. It's going 2 knots due south. So I'm literally drawing the arrow in the south direction. Okay, so let's combine these two arrows, if you will, and do some simple vector mathematics. And this is where I think this is going to be pretty interesting for those of you who have never seen this before. All right, so here is our boat. Okay, I'm going to draw this really big right here. And we're going to plot this in the center of our little compass here, okay, our little heading. So here's 0, 0. So basically, here is our boat. Matter of fact, I'll do it this way, and then we'll take a look at the compass heading. So the boat's speed and direction is 15 knots due east. Okay, so remember, its arrow looks like this. Now, what we're going to do is add the current, the vector for the current, but we're going to start, this is the tip of the arrow. Well, this is the tip, excuse me. This is the beginning of the arrow. This is the end of the arrow. So we're going to take the second arrow and we're going to start it at the tip of the first. So basically, this is our current. Okay, so here's our boat and here is our current. Okay, all right, so once again, we are accounting for the speed and direction. So here's the boat and here is the current. And the length of the arrow of the boat, again, is longer because the length represents speed. Okay, the longer the arrow is, the faster that means. So here the current obviously shorter. All right, now here is the big deal about vector mathematics. So to get the actual true direction and speed of this boat, we're going to do something called the resultant vector. Resultant vector, what's that, Mr. YouTube Math Man? Well, the answer to this question is this. We're going to start from the first arrow and we're going to draw an arrow to the tip of the second. Okay, so from here, we're going to start from the the beginning of the first arrow, and we're going to go out to the tip of the second arrow. So from here to here, basically we're going to complete this little triangle. All right, so this triangle right here, the length of, I'm sorry, this triangle being formed, this hypotenuse, and we'll get into the math here in a second, but the length of this arrow is the speed, represents the speed. Remember, we're talking about arrows or vectors, right? Where the length is the speed. So if we can determine the length of this side of the triangle, well, that is the speed. And then we need to do some fancy mathematics to get this angle right here. Okay, now before we get into the math, let's just make some observations here. Our boat is going due east 90 degrees, right? So it's going 090. That's the direction of the boat. And the current is going due south, which is what? 180. So if we compare these two arrows right here, this is 90 degrees, right? So the current is 90 degrees more. So this forms a right triangle, okay? So we have a right triangle situation, which means that we're going to be able to use something called the Pythagorean theorem to solve this problem, at least for the length of this side of the triangle. All right, so stick with me because we're going to get into the math right now, but this is effectively the summary of the setup. Okay, so here is our boat, 15 knots. Here's the current, 2 knots. Okay, and notice again, that vector is starting at the tip of the first, and then we're going to connect the tip, the beginning of the first arrow to the tip of the second. So this problem comes down to we need to find this angle right there and the length of this triangle. And that will be the boat's true speed and heading, okay, or direction. This word right here, heading, means the direction of the boat. Okay, so now let's go ahead and get into the actual math, and we'll start with figuring out the length of this side of this right triangle, right? Okay, so remember these sides here, this is the boat's speed, and this is the current's speed, and it does form a 90-degree right triangle. So we can use the Pythagorean theorem to solve for this side. Now, this side here is the longest side of this right triangle, which is always C. And of course, this is called the hypotenuse. So this could be A, this could be B, and this longest side right here is C. So let's go ahead and solve for C's, and we're just simply going to plug in these two values for our sides. So 15 squared is 225 plus 2 squared is 4, and that's equal to, let's just call this side x, x squared. All right, so let's finish up this math right now. And here we have 225 plus 4, that's 229. So x squared is equal to 229. So to solve for x, all we have to do is to take the square root of both sides, and we're going to get x is approximately equal to 15.13. So what does that represent? Well, that is the boat's true speed when we account for the current. So the current's actually helping it out just a bit. All right, so now we're going to get into the next part of this problem, which is going to require some basic trigonometry, and that is to determine the angle, this angle right here. So let's go ahead and take that next step, which of course is having you quickly subscribe to my YouTube channel. Now, I wouldn't stop this lovely math video if I didn't need your help, okay? I need your help, and I'm not shy to ask for it. My goal is really to teach as many people as I possibly can mathematics, and to teach it in, in a way that doesn't feel like a classroom. There is a time and place for formal instruction, and I'll talk about that in a second. But my YouTube videos, are really, trying to, make them where anybody could watch one of my videos, even if you don't have the math background, and still get something out of it. Okay, really try to make math clear and understandable. And most importantly, I try to offer a lot of encouragement. Like, do not give up. I know math can get difficult at times, but don't give up. But I need your help to get this message out to people on YouTube. And the best way to support this channel is simply to hit that subscribe button and that notification bell as well. And if you need real true math help, and the things that we're talking about here, you can find in my pre-calculus course. So that's the course where I really teach about vectors and all the trigonometry that we're going to be doing here in a second. So if you look in the description, you'll see links to all my full main math courses. Also, you'll see a link to my Shopify store where I offer digital products like notes and downloads like that. So let's get back to the rest of this problem, because now we have to get into some trigonometry. All right, now if again you don't understand basic trigonometry or basic geometry, don't get overwhelmed. This is just a quick video explaining these topics. If you really want to learn this stuff, check out more of my videos on YouTube, or again, one of my full main math courses. All right, so now we know that this side of this right triangle is 15.13. That represents the speed. But now we need to get this angle right there. So how do we find this angle? Well, we have to think about basic right angle, okay, because we have a right angle trigonometry. So that's different than trigonometry that involves triangles that are not right triangles. So I'm not gonna talk about this other than just mentioning it. When you have a triangle that's not a right triangle, something like this or something like this, well, the math gets much more interesting. These type of triangle problems require something called the law of cosine and the law of sine. Okay, that's beyond the scope of this video. But what we're going to be doing here is solving this basic right triangle situation. So when you have a 90-degree angle in your triangle, well, then we can just use basic trigonometry. So I know that makes you very happy. Like, yeah, you must do too, math man. Let's go ahead and finish this problem up. All right, so we want to find the angle, and let's kind of observe what angle are we focused in on here in this triangle. Well, there's three angles, right? So we have this angle right here, we have this angle over here, and we have this angle. But the angle in question is this angle right here. We need this angle, and you'll see why in a second. So with respect to this angle, there's three sides to this right triangle. And that's going to get to this little phrase right here, so cut toe. Matter of fact, let me just tell you what these O, H, and A represent. Okay, so here O is opposite, H is hypotenuse, and A is adjacent. Okay, so with respect to this angle, the adjacent side is the side next to the angle. Okay, that's what adjacent means. So this side right here, 15, is the adjacent side. Now, what is the opposite side of this angle? Well, we have to look opposite of the angle. So here's the angle way over here. This is the opposite side of that angle. And then H is the hypotenuse. The hypotenuse is always the longest side of a right triangle. So with respect to this triangle, what information do we have? Well, we have for this particular angle. Well, we know the opposite side, right? We have 2. That's the opposite with respect to this angle. And we have the adjacent side, that's 15. So we have to use the information given. So which one of these trigonometric ratios, by the way, I didn't even tell you that. Let me tell you this real quick. I'm kind of jumping ahead of myself. Sine, okay, the sine of an angle is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse, and that's where these little sayings here, so, cut, toa, come in. But here, again, we have the adjacent and the opposite. So which one do we have to use? Well, the only one that has opposite and adjacent, that's what we have, is t, or the tangent. Okay, so the tangent of this angle is equal to the opposite over the adjacent. Okay, so I'm trying to, do a quick trigonometric review for those of you that never, done any right angle trigonometry. This stuff is not that difficult. So the tangent of this angle is equal to its opposite over adjacent. Now we know these sides, that's going to be 2 over 15. So let's take that 2 and divide it by 15, and we get 0.133 repeating. All right, but again, we need to find that angle. So to find the angle, okay, that where basically you're going to use your calculator and say, all right, calculator, what angle, okay, has a tangent of 0.1333 repeating? Well, you have to use this button right here. Okay, that's called arctangent. Now, for those of you that really want to kind of do the work on a calculator, you typically have to use like your second function and just go to your tangent button, and that will bring up your arc function. Okay, this little -1 right there. And so we're just going to plug that into our calculator. We'll pull up the arc function and then type in this decimal, 0.1333. And by the way, make sure that your calculator is in degree mode. There's other modes it could be in when it comes to angles like radians. And when we do all this math, we're going to get approximately 7.59. And if you're in degrees, that means 7.59 degrees. That's the angle right here of this triangle. Okay, so we're almost there, and I know a lot of you are like, Mr. YouTube Math Man, this is just too much. Why not even watch this video? Well, we're almost done. Okay, we're almost done. All right, so as I indicated, if you were able to solve this, you're pretty good in math. Okay, so here is our kind of overall setup from the very beginning. So here is the boat. Okay, this is the boat. It's going due east at 090 degrees, and then the current is having an effect, that 2-knot current going due south. Okay, it's certainly pushing the boat, and it's pushing it in a southward direction. Okay, that current, right? So the speed of the boat, the true boat speed, we figured out is 15.13. But the true direction is not just this angle. Okay, this angle is 7.59. All right, 7.59 degrees. Now, if you said, hey, let's take the boat and go in a direction of 7.59 degrees, well, that would be like here's 0 degrees. That's over here. Okay, that's not the actual direction. The direction of the boat where it was originally traveling was 090 degrees, but we have to tack on that additional 7.59 degrees, so 90 plus 7.59 is obviously 97.59 degrees. That is the true direction or heading of the boat. Okay, so covered a lot of things in this problem. Again, if you were able to solve this all on your own, that's pretty impressive, okay? That means you understand vectors and basic right angle trigonometry. But, even if you're like, there's no way I can learn all this stuff, you absolutely can learn this stuff. Okay. It just takes time and effort and especially great, clear, and understandable math instruction. And that's what I try to do on my YouTube channel. So if you got something out of this little video, make sure to hit that like and subscribe button. And with that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.